All right, so we're doing question number 3, A, and this says using a ruler, a pencil, and a pair of compasses, we're to construct the right-angled triangle ABC such that AB is equal to 5 centimeters, angle ABC is equal to 90 degrees. Now please listen to this. Whenever 3 letters are used to reference an angle, the angle is always at the letter in the middle. So this is telling me that I'm going to construct a 90-degree angle at B, and I'm going to construct a 90-degree angle at A. So essentially, this is how it's going to be done. I'm going to do a sketch here first. First, I'm going to draw AB. Now, at B, and AB is 5 centimeters. At B, I'm going to construct a 90 degree, 60, 120, and I'm going to draw this all the way up. At A, I'm going to construct a 60-degree angle. All right, and I'm going to draw this all the way up. Anywhere the two lines intersect, that is going to be the point C. So essentially, that is how this construction is going to be done. Let me see if I can show you how to do that on a different application. All right, so the first thing I'm going to do is I'm going to draw the line AB of length 5 centimeters. So this is the line AB of length 5 centimeters. I'm not able to write the word A and B. If that can be done, I don't know how to do it on the application. But that is the line AB, and the length is 5 centimeters. Remember, as we discussed a while ago, we say that at B, so A is to the left and B is to the right. At B, I'm going to construct a at B, I'm going to construct a now at B, I'm going to construct a 90-degree angle. All right, so this is how this is done. Start here. All right, so start around here. All right, so I open my compass to a suitable radius. And with B as the center, I'm going to scribe a very wide arc. Apparently, I did not do that so well. So B as center, I'm going to scribe a very wide arc. So that's my arc. Now, without shifting the compass, I'm going to move now the compass and put the compass, the metal tip of the compass, where without shifting the compass means that the radius of the compass must not change. I simply just move, after I scribe that arc, I simply just move the metal tip of the compass from B and put it to where it intersects, where that blue line intersects the black line. So that is sort of like my 0 degrees. Then, so the metal tip is there. So I scribe the arc. Now that arc, where that arc cuts, if I draw a line from B through that point where the two arcs meet, I would get 60 degrees. But I don't want 60, I want 90. So here at 60, I put back the metal tip. All right, I'm going to scribe a second arc. Now, where that second arc, again, for this entire construction, I do not shift the compass. Where that second arc cut the first arc, a line from B through that angle will give me 120 degrees. All right, now 90 is in the middle between 60 and 120. So with my metal tip still at 60, I'm going to scribe another arc. Metal tip at 60, I scribe an arc. Then without shifting the compass, I move the metal tip back over now to 120 and I scribe another arc. Sometimes this thing don't behave the way you want it to behave. All right, now a line from B through where those two arcs intersect will give me 90 degrees. Let me see if I can do that, if I know how to do it. All right. All right. How you do this now? Aha. All right. So let's try and get a straight line. All I want is a straight line. All right. This doesn't move it. So this doesn't move it. All right. This is telling me that this thing is not perfectly done. All right. Can I undo? Move this over a little to the right. Good. Then, all right. So I get my 90-degree angle. Now at A, I'm going to construct a 60-degree. And then I'm going to draw up my line at 60 degrees, and anywhere it cuts anywhere it cuts that line I just draw, that would be C. So I pull over now my compass. So at A now, I'm going to construct my 60-degree angle. So I do that. Then I move the metal tip to here. All right, things are not going perfectly, but at least you get the basic idea of it. So now I need to bring back my ruler. All right. All right, and I want to try and get once I feel it's lined up, I just draw my line, move that. And this would be my construction. This would be the triangle ABC. Where that 60-degree line meets up by the top, meet the line from B, that would be C. Now, if I was doing this on paper, obviously, I mean, we would not have our lines passing the edges, and it would be a lot neater. But in essence, these are the construction involved. If you want to, and this type of construction, really what you're doing is you're constructing a triangle when you're given two angles on one side. This is how the construction would have been done. All right, so question 3B says the diagram below shows a right-angled triangle with sides A units, B units, and C units. We're asked, using the diagram, we're to ask to express in terms of express C in terms of A and B. Now, the mathematical concept that connects C and A and B is Pythagoras Theorem. So Pythagoras theorem says the square of the hypotenuse, which is c, is equal to the sum of the squares of the other two sides. So c square would be equal to a square plus b square. All right, this is the Pythagoras theorem formula. If I want, I could say that c, the opposite of square is square root. I don't think that this is actually necessary, but if I wanted to, I could have done that. So this would be a square plus b square. So c is equal to the square root of a square plus b square. I think that c square is equal to a square plus b square would have been enough. Next, we're told at B to write in terms of A, B, and C an expression for sine theta plus cosine theta. Ladies, now the side in front of theta is the side that is opposite to the angle theta. So A is the side that is opposite to the angle theta. The side in front of the right angle is the hypotenuse. So C is the hypotenuse. And then therefore, B must be the side that is adjacent to the angle theta. So the sine of theta, sine theta is opposite, which is what? A over hypotenuse C. Sine theta is opposite A over the hypotenuse C. And cosine theta is adjacent B over the hypotenuse C. So sine theta plus cos theta is the same as saying A over C plus B over C. So we're asked to write in terms of A, B, and C, an expression for sine theta plus cos theta. So we have done that. Next, we're told, using your results from I, A, and B on page 12, we're to show that sine theta square plus cos theta square is equal to 1. Remember, sine theta was equal to A over C. So sine theta square would be equal to A over C multiplied by A over C. When you square something, you multiply it by itself. So this is A square over C square. Now, cos theta square would be equal to, remember that cos theta was equal to B over C. So this is B over C times B over C. This is B square over C square. So sine theta square plus cos theta square is the same as saying A square over what? C square plus B square over C square. Guys, if you're adding two fractions and the denominators are the same, you simply add the numerator and keep the denominator. So this is A square plus B square over C square. Now, according to Pythagoras theorem, A square plus B square is equal to C square. So this is C square divided by C square. This is equal to 1. Lastly, we were asked to show that sine theta square plus cos theta square is equal to 1, and we just did that.